Welcome to this new video where I'll be showing you how to create this. That's supposed to be an electronic piano that I've made using conductive PLA and normal PLA for the bass substrates. As you can see in the diagram, the PCB is connected to an Arduino using jumper wires, and I've used that silver glue to make sure I've got good connection between the jumper wires and the conductive PLA. The pins on the Arduino to which the keys are attached are floating, and by touching each key you're grounding those pins, which the computer will then detect and then generate a sound like you would if you pressed a key on the piano. And it sounds something like this. So if you'd like to see how I did that, then hang out and let's get started. If you're unfamiliar with using Solvespace, then please check out my CAD challenges 1 to 10 where I use Solvespace to solve those challenges. Okay, let's create one of these keys first in the piano down here. So using the line segments tool up here, I'll create an outline for one of the keys first. Something like this. And it doesn't have to be perfect to begin with. And to close the contour, I'm going to use the arc tool over here. Okay, let's constrain the orientation now of these lines. I want this line to be horizontal, so I'll select it and click here. Constraint to be horizontal, and let's do the same now for the others. I want a couple of the lines now to be vertical, so I'll select this one and then here, constraint to be vertical, and the same with this one. It wouldn't make much sense to constrain the length of each one of these individually. What you can do is select them in pairs and tell Solvespace that you want these pairs to be equal in length. So I've selected them, you can see they're red, and then I click here, constrain equal length. If I select these two lines, one of them already constrained, it means that this one now will adopt the same constraint as this one. Clicking here again. And I want these two to be equal in length, and by doing that it makes sure that this extension is in the middle of the key. Okay, we've got 7 degrees of freedom left, and that's partly because I've not stated what length I want the sides of this key to have. Now that these 3 lines are constrained to be equal, if I select one of them and constrain its length by clicking here, constrain distance, it means that the other 2 lines will adopt the same length. I want this one to be 10 millimeters. So let's just drag those lines in closer. And you can see it looks a little bit of a mess, but not to worry. It'll soon look better in a minute. See these 2 lines? Well, I want these to be equal in length as well. So I can select them and click here. And now I can specify the length by clicking constraint distance and typing in 10. We'll come to the arc in a minute, but before we do that, I want the minimum thickness of the wire, the PCB wire, to be 3 millimeters. Just like we discussed in the last video. I can do that by selecting these 2 points, clicking here and typing 3. Now we've got 3 degrees of freedom. 2 degrees of freedom is because I can move the whole thing about, and 1 degree of freedom is because I can adjust the diameter of this arc. So let's start by anchoring this. So I'll select this point, and you can select any point on here that you like. I'm going to select this one and the origin and click here, constrain point on point. Now we've got 1 degree of freedom left, so I'll select the arc and click constrain distance or diameter, and I'll click 8 here. I'll select the circle tool, click on the center here and drag out, and let's constrain this circle to have a diameter of 2 millimeters. With a diameter of 2 millimeters now, the difference here between this line and the outer circumference is 3 millimeters. So this is a thickness of 3 millimeters, and we have a distance between these 2 lines of 3 millimeters. And that's one of the keys done, but I need to have two more. So let's just click and drag to select it, and then edit and go down to copy, or just click Control and C on your keyboard, and then Control and V to paste, or edit and paste. And we need another one of these. And we have 4 degrees of freedom, and that's because these two keys can both be moved along the X and Y axes. So let's constrain the movement of one of the keys first. I select this point and this point and constrain them to be horizontal to each other. Why did I do that? Well, it's because I can now only slide it in the X axis and not along the Y axis. Let's do the same thing for this one. 2 degrees of freedom left, and that's because I can move both of these along the x-axis. So let's constrain the distances between them to be 10 millimeters. I think 10 millimeters is probably just enough to get your finger to be on one without interfering with the other key. Okay, we've fully constrained this. Let's extrude it by clicking here. I'm going to use the middle mouse button again to rotate the model. I'll select one of the extruded axes and constrain its length to be 3 millimeters. So let's go to File, Save As, and I'm going to save this as a Solvespace sketch. I'll call it Piano Keys. Great. Okay. File, New. Let's start work on the base. Click on Rectangle tool and create a rough sketch. I want the length of it to be 60 millimeters and the width 35 millimeters. And let's anchor it in the usual way. And now extrude the model and give it a depth of 3 millimeters. Let's save it as a Solvespace file. So I'll go to File, Save As, and I'll call this Piano Base. It's also a good idea to export it as an STL file ready for 3D printing. So I'll go to File, down to Export Triangle Mesh, and I'll also call it the same name, Piano Base. The next thing I need to do now is to make sure that the keys have the correct global coordinates relative to the base, so that when we print it out, the keys will be on top of the base and in the correct position on the base as well. That'll become clearer now. Let's now bring in the keys. So I'll go to New Group this time. On the menu bar, go down to Link, Assemble, and I'll select the Piano Keys file, which I just created. And you can see that the keys aren't in the right position relative to the base. I'll use my middle mouse button again to rotate the model, select one of the points on the wires. Let's constrain the orientation now of the wires model to be the same as the base. So I'll select this normal line and that one and click here. Constrain normals to have the same orientation. Next thing I want to do is to place the keys on top of the base. So I'll select one of the points at the bottom of the keys and the top face of the base and click Constrain Point on Plane. You can see now that they're flushed. Click W on your keyboard, and all I'm going to do now is eyeball roughly where I want the keys to be relative to the base. So now we have the global coordinates of the keys relative to the base, so that when we print it out, the base will be at the bottom and the keys will be flushed on top. I can now head into my properties panel, selecting the first sketch for the base, clicking on there, and then click here, delete, click OK. All right, now these keys are now positioned properly relative to the origin. You can see that they're kind of hovering 3 millimeters above there. Now we can export this as an STL file. So let's go to File, Export Triangle Mesh, and I'll also call this Piano Keys. Now we're ready to use the STL files for 3D printing, so let's do that. To get things ready for printing, what I need to do is select and drag the base and wires file into Cura. And I need to make sure that the base is printed by Extruder 1 and the wires by Extruder 2, which contains the conductive PLA. Here I'm checking to make sure that the temperatures set for nozzle 1 and 2 are both 210 degrees. By merging them together, you see that the wires are now flushed on top of the base. I can slice the model and then save it onto an SD disk and put that disk into my 3D printer. Here's the result, not too bad. Maybe I can change the quality of the print by tweaking the temperature a bit. Here's a schematic of what the piano looks like. You can imagine the piano key as a push button switch. It's currently open and pin 3 is currently floating, which means that its voltage values are dependent on fluctuations in the environment. But when you put your finger on the key, it's like closing the switch, causing you to ground that pin, and then the voltage will go down towards 0. Okay, let's move on to programming the Arduino. And for this sketch, I'll be using an Arduino Mega board. Here I'm defining variables to hold the voltage values for pins 3, 4 and 5, and then an array for holding those values together. In the setup part, I'm defining the baud rate to be 9600, and that's the amount of signal changes that can happen per second. In the loop block, I'm reading the analog values for those pins and storing them in the variables, and then filling up the array with those variables, and then finally printing out a single string as a comma separated value. And that comma separated value is then sent by serial communication via the USB cable to the computer. I've added a 200 millisecond delay just to slow down the communication a bit between the Arduino board and the computer. Okay, so we've printed out the piano, we've programmed the Arduino, which is now sending serial information to the computer. The next thing we need to do is somehow capture that information in the computer and then respond accordingly when we ground one of those pins. Every programming tool generally has a way of reading serial information that comes into the computer. But some programming tools are better than others at integrating hardware and software together, by allowing you to create something quickly either to prototype or as a final product. These tools generally come under the umbrella of creative design tools such as Touch Designer, Processing, Open Frameworks, VAV, Vuo and Quartz Composer, and there are a few others as well. These tools are all programming tools, but some of them are textual based, which means you type in your code, and others are visual programming tools. Today I'm going to focus on Vuo. Now Vuo will run only on the Mac. My experience of using Vuo is that it has a very clean user interface, which I'll have a look at in a second, and it also has a really friendly community. The website explains what Vuo is and why you should use it, and they go on to say, for example, it's interactive, you can integrate stuff with it, customize stuff with it, but this is a really nice way of explaining what it is. It helps you bring your ideas to life, and it really does. It allows you to integrate hardware and software very easily and quickly. When you open up Vuo, you'll have 3 panels. This one is your node panel that lists all these different types of nodes here, and then we have a documentation panel down here. For example, if I select one of the nodes, it tells you something about it, and at the bottom it'll give you a few examples showing you how to use that node as well. This here is your spreadsheet. This is where you create your composition. So let's get started. So if I've never used Vuo before and I want to find a node that has something to do with serial, I just need to type serial in the search panel and it lists me everything that's to do with serial communication. So that looks like something we could use. So let's click and drag that and drop it in there. You see that this node has a title which you can double click and change if you want. It has an input port and an output port, and from that output port I can click and drag a wire that will carry data and events. Let's start by specifying what device I want to receive data from. So I'll double click on that and select my Arduino, which is listed down here. If I hover and click on the output port, it tells me what data type it's going to give out, which is a binary data. So let's just click let's just run this composition by clicking here, and if I click on here, it's telling me how many bytes of data I've received. And the way I got this little pop-up window was to hover over the output pin, click on it. There is another node that's very handy for us right now, and it's called Split Text Stream, and it's over here. We have a typecasting here now from a data or binary data type to a text data type. It's asking me as well for what type of separator do I need to use to separate the different lines of data that's coming in, because right now we just want to isolate every single line that comes through the stream. And for that we need to tell it that we're using a carriage return or a new line character. Now if I select and click on the output pin, you can see how amazing Vuo is. It shows you what values you're getting through and what data type we have. And just remember as well that coming through these pins you have data and events. Let's do something useful and render the values as a text on the graphics layer. So let's type in text, and it says here make a text layer, and the text layer by default has hello world in there. I can click and drag a wire into that input pin for text. Hovering over here tells me that we now have a layer data type that's been created by this node, but we're not seeing it just yet because we need to render that layer. So here I'll type in render, and it says that we've got different types of rendering. We can render layers, scenes and images. Let's go with a layer, click and drag that in here, tidy it up a bit, and let's just do that. Now if I look behind here, you see that we have a new window that's popped up. Our text being printed down here. I can change the text now in real time by going to my make layer text node, double clicking on the font. A pop-up window will appear and I can just change the font size. Okay, the next thing I need to do is to be able to take the 3 separate values from each line, and there's another really good node that we can use, and it's called split text over here, and it says that it separates the text into parts. So I'll click and drag from here this time. You can either click and drag from here or from here. I'll take a wire from the output and put it into here, and if I hover over the output pin of this, it's telling me that we're getting a list of text elements, but we only have one element coming out, and that's the actual line of data that we had put in originally, and that's because we've not specified what's separating the values in that line. And if you remember, we're using a comma separated value, so I can click on the separator input pin and type in a comma, and now you can see that we've got a list of text elements, and we've got 4 elements here, 3 of which have the number, and the 4th one, it looks like we've got some sort of a terminating character in there, like a null character maybe. Before working on all 3 pins, I'm just going to focus on working on 1 pin. So I need a way of extracting the first value from this list. So let's head back into the nodes panel here and see if there's anything we can use. I'll type in list, and it says here get item from list, and it says that we can select 1 item from a list. That sounds like something we can use, so I'll click and drag it over here. I'll join these up like that, and it's asking me as well, which element do I want to select? Well, I'll select the first one, number 1. In Vuo, the first element in the list is numbered from 1 upwards. And now if I hover and click on its output pin, you can see that we have a single text value that's coming out. Okay, that's all good. Now what can we do with that value? Well, we need to test the value to see if it's been grounded, and if you remember, if we ground one of the pins, its value will approach 0. So let's see if there's a note here that we can use. I'm thinking, is there anything here similar to less than? Is less than is a simple one we can use. But there's something we have to be careful of here, and that is that we want to make sure that we're converting this text into an integer value that the less than node can use. So if I right click on the input port, I can set its data type to integer. Now if I drag a wire from here into that node, let's check to see if the value is less than 50, and if I hover and click over here, we're getting a boolean value coming out. Now that we're building up this composition, I need to bring in one of my sound files, and on my desktop I have a sound file labeled key 1 mp3, and I can just click and drag that and drop it anywhere on the composition. And if I don't know how to use this node, all I have to do is select the node and have a look in the documentation panel. It tells me that it outputs a stream of audio from a file, and further down in the documents panel we have another example. So I'll click and open that, and it looks like we need another node to be able to use this properly. It's called the send live audio node, and all that does is it sends the audio signal from the file to the device that generates the sound. So we'll select that node, copy it, and just paste it into here. So I'll hook these up. What I need to do now is find a way of sending a signal from this conditional node into this node. So if this value is true, then I want to play this. And there is a node that we can use. It's called select event input, and it says that it routes the selected input port's event to the output port. Okay, so an event is like a firing signal that tells you to do something if you receive that signal. So let's hook these up like this, and now you'll notice that this wire becomes thinner here because we're sending an event now to here. Now let's hook up this to here and see what we get. And this is what it sounds like. If I touch that key again and try and play it, nothing happens. And the reason for that is because once the MP3 file has finished playing and reached the end of the file, there's no way of rewinding it to the beginning. But if you look at the node, we have a finished playback output node which fires an event, and we can send that event back onto one of its input pins to set time to 0. And what it does is, once it's finished playing, it'll rewind the MP3 file to the beginning of itself, so then I can keep pressing the same key. So let's do it now for the other two. All I have to do is select and copy that set of nodes and then paste it twice. Making sure over here that I'm selecting elements 2 and 3. I now need to make sure that I'm playing the right files for the other two. I rename this one to key 2 and this one to key 3. Okay, let's see what happens now when I select the keys. And incidentally, I am touching a copper pipe next to me here, just to make sure that I ground myself. Can I select them both at the same time? Kind of. So this is the whole composition that we've created, no typing involved. This is the resulting algorithm. Now you can refactor this either by coloring the nodes in the way you want, or maybe simplifying what I've done here, because I have repeated myself 3 times here, and there is a way of refactoring that, but I'm not going to show you in this video. If you want to know more about Vuo, you can check out the website like I showed you before. They have a very good user manual there as well, which explains a bit more about what the different nodes are, about event cables and data cables. So you should go and check that out and see what you can come up with. Also, think about ways in which you could improve on what I've done. And incidentally, if you wanted to ground pins on an Arduino, you don't have to 3D print something like I've done. You could hook up the pins to bananas if you like and see what you get with that. In the next video, I'll be showing you some results I've had testing out the conductivity of conductive PLA, as well as making my own. So I'll see you there. Bye.